Namaste to all of you. I'm covering a subject on constructing a sustainable future using sustainable concrete practices for high rise and villa constructions. I have taken construction of the buildings to achieve the net zero wastage and net zero carbon. Yeah, can you all hear me?
Yes, sir, you are audible.
So, topics covered here is vision, net zero wastage, and net zero carbon. OPC based concrete versus SEM based concrete mixes, the game changers, and benefits of SEM blended concretes, on site handling, quality control, and a case study of the raft foundations I have involved. So, coming to the vision net zero carbon, the three visions I am highlighting here is net zero carbon. This is a keeping in mind, as Manish sir has mentioned, net zero, 2070 vision. Our India's vision for 2070 is net zero emissions. So, with that vision, I kept this achieving a balance between the amount of greenhouse gases emitted and the amount of carbon removed from the atmosphere. And net zero waste in construction, eliminating or drastically reducing the waste generation through the entire life cycle of the construction project, from design and procurement to execution and demolition. So it's not just about recycling, but it's about designing out the waste entirely, how we can design and execute with minimum waste, that is to achieve the net zero waste in the construction. And third point is reducing embodied CO2 emission. So by cutting the carbon released during the production, transport, and installation of the building materials. So these are the three concepts we are discussing here. So notice net zero carbon is a long-term operation goal throughout the project life cycle, while embodied CO2 reduction is an immediate design and procurement strategy. So that is designing the right concrete mixer design using SEMs, as our panelists has already explained, and reducing the selection of the right materials. I mean, SEM supplementary cementitious materials like fly ash, ultrafine fly ash, or GGBS, steel slag, and procuring it from the local plants. So, is the concrete construction or a destruction material? As we all know, the concrete is most widely used substance on the planet after the water. So concrete now is being called also as most destructive material on the earth because it is producing because of its production and use is inflictive massive environmental damage at every stage. So producing 1 cubic meter of conventional concrete, say for example M30, if we are using 300 kg of cement, you are getting almost 300 kgs of CO2 emission, which is almost 40% of which coming from the clinker production process. Already our panelists, Dr. Bhattacharji and Singhji, has explained how to reduce this clinker emission, CO2 emission from clinkerization. Overall, cement and concrete manufacture account to around 4 to 8% of the global anthropogenic carbon emissions, human-made activities, matching the entire nation's output. It's almost one nation's output. Global cement manufacture emits about 69 million tons of CO2 per year. Globally, cement industry is releasing 69 million tons of CO2. And 51% of that comes from the chemical calcination of the limestone process, clinkerization. So these are the emission factors of each cementitious materials. So if you see the first line, ordinary Portland cement is contributing almost 1 kg of CO2 emission per 1 kg production. So by replacing this cement with GGBS, we can bring it down to almost 0.15 kg of CO2. Means almost 85% of the CO2 emission is reduced. And even fly ash, we can reduce far more, almost 95% of the emission, fly ash replacement. So fly ash, if we replace cement with fly ash, we can bring down the carbon emission from 1 kg to zero point 0.05 kg. So these are the remaining factors. Majorly, we are trying to focus on fly ash or ultra fine fly ash and GGBS. So the percentage of the SCM compositions which we can go is as per the standards we can go. If we go for Portland limestone, up to 10 to 15% limestone can be used, and fly ash as per standards up to 25 to 35% fly ash we can replace the cement. Steel slag 35 to 45, and LC3 40 to 50%, and natural polymerase blends are around 30 to 35%, which contributes to reduction of embodied carbon. So this is the statistics of overall carbon emissions. If you see the map, China is contributing almost 300 million tons of CO2, and India is producing around 110 million tons, then followed by United States 60 million tons, then Indonesia, Vietnam, and Turkey between 10 to 40 metric tons. So this is the volume of CO2 being emitted by various countries. So carbon emission, one minute. Reduction versus OPC cement. Emission resources in cement. The emissions shown stem mostly from calcination of limestone, fuel combustion in the kilns, electricity usage in grinding and handling, plus minor contributions from transportation and quarrying. So these are contributing to the emission of the CO2. And relevance to sustainable concrete practices, as this map we have seen underscores where interventions with SCMs, fly ash, GGBS, and calcium clays can offer the biggest CO2 savings. High emitting countries have a critical opportunity to embed low carbon concrete in public and private projects. And the map highlights the global urgency and regional responsibility in scaling sustainable alternatives. So, how to achieve net zero waste in construction of high rise or buildings? First thing is sustainable design and material optimization. So, we need to, before going to execution, in the design itself, we have to do optimization. Circular procurement and material planning, smart QAQC systems and waste monitoring, mixed design innovation, construction execution controls, documentation and compliances, end of life and demolition planning, training and building the culture. So we have to build the culture throughout the project on daily inductions to the project personnel. So sustainable design and material optimization, as we discussing, we can replace up to 30 to 70% of the OPC using the SCMs, fly ash, GGBS, silica fumes. And we can still optimize the structural designs. Whatever the structural designs we have, we need to do the proof check from the superiors or expert consultants who are good in concrete and structural designs, so that the design given by the structural designer is adequate, not over or redundant. And we can adopt modular and prefabricated elements to minimize on-site cutting and formwork wastages. So circular procurement, we can use building information modeling software for extracting the quantities, exact take of material quantities, and we can source the recycled aggregates. So nowadays we have construction and demolition waste recycling plants. So we can look for the recycled aggregates and certified low carbon materials like gypsum plaster, If you see, there is a natural material we can use, and instead of normal cementitious plaster and recycled steel. If we use recycled steel, we are avoiding the use of virgin materials. Under vendor contracts with waste return clauses. So we should have vendor contracts. So whatever the wastage materials are there, we return back to them for recycling. Smart QAQC and waste monitoring. So implementation of the quality tools like digital tools can help us track how much materials are being used and versus design quantities. Daily work inspection audits to flag overpouring, rejected batches or rework, which can help us in controlling the quality. And tag and segregate the waste streams. So we can segregate all the waste generated at the project, like concrete slurry or debris and shattering wood, steel scrap, packaging material. All this we can segregate at the project. So mixed design innovation, use of performance-based concrete mixes, which will be tailored for pumpability, early strength, and reduced heat of hydration. And trial low carbon SCC self-compacting concrete for vertical elements to reduce formwork and vibration energy. And incorporate recycled waters for concrete mixing or curing and aggregates where feasible. So we can keep smart QAQC key performance indicators so that project manager can monitor how to reduce, how much we are reducing. So this is the main key, driving factor which can help projects to reduce the waste. So set the KPIs, key performance indicator, like implementing the triple R policy, reduce, reuse, recycle, and standardized approaches, 5M approach across the project, manpower management, materials, machinery, methods, and measurement of quality, cost optimization, timely delivery. Gap analysis. At regular audits, we have to do gap analysis and take improvement actions and optimizing the procurement and inventory management and ensure zero defects. Coming to environmental objectives, optimize the water and energy consumption, adopt circular economy principles, carbon footprint reduction, vendor and supply chain compliance. So end of life and demolition planning, design for deconstruction. So use the use of bolted connection, modular slabs, and separable finishes. Plan for recycling of concrete, steel, and MEP components. Segregate demolition waste for reuse in landscaping, subbase, and new constructions. Training and culture building. Conduct workshops for site engineers and contractors on SCM handling, waste generation, and sustainable concrete practices. Reward zero waste champions and teams with lowest rework and highest material efficiency. Embed sustainability into the induction product programs for all site personnel. So environmental and sustainability benefits, reduced carbon footprint, replacing clinker-based cement lowers CO2 emissions by up to 40% per cubic meter. Waste valorization utilizes industrial byproducts like GGBS, fly ash, instead of diverting them from landfill and contributing to the circular economy. Improved resource efficiency. SCM supplementary cementitious materials typically require less water and energy to produce, making the entire supply chain greener. Lower embodied energy. GGBS and fly ash blends reduce energy intensity per cubic meter of concrete placed. Enhanced lead or IGBC score contribution. So replacing with these OPC with SCMs, GGBS and fly ash helps in green
So
building
sorry to
credits.
interrupt. Can you please wrap up the presentation in next 2 minutes? We are
Yes,
we already crossed
yes,
10
sure,
minutes.
sure, sure. So, just a few case studies from my past experience in Dubai and Amravati Secretariat in Andhra Pradesh. We have used almost 60% OPC replacement for raft foundation in Dubai next to Burj Khalifa. It's almost 4 meters thick raft, 3.75 meter, uh, using GGBS 60%, 40% OPC. These are Amravati mixed designs where we used almost 60% GGBS in two different projects, and one project with L&T we have used fly ash and GGBS 50%. This is the project in Andhra Pradesh where we have, sorry, yeah, it's a 4 meters thickest raft in India. We casted using the 40% OPC and 60% GGBS, temperature controlled concrete. So we have done mock-ups also. Yeah, it's a mock-up to monitor the temperature control, temperature rise. In temperature control concrete, we have to limit the temperature up to 69 degrees maximum and variation within 20 degrees between the core and the surface. So thermocouples are inserted and monitored before we do the mass pour. The challenges in raft foundation is cold joint formation and thermal stresses. So both are being taken care by proper mixed design. So these are the tests being conducted: compressive strength, water permeability, water absorption, ISAT, initial surface absorption, rapid chloride permeability. So monitoring of the slump of each truck for consistency and temperature helps us avoid any thermal cracks and consistency of the concrete. These are the few photos of durability tests: modulus of elasticity, rapid chloride permeability, water penetration, compression tests. So the things what we have to take from here is we all have to act as a change agents. From now, we need to educate the project's personnel that we should work with the sustainable materials and SCMs to bring the culture into the projects that, and we have to drive this as a culture, adopting the sustainable materials, SCMs especially, and let us build it for future generations, celebrate progress, not only perfection. Collaborate across the functions, engage quality assurance, HSE, planning, procurement, all together has to work, not in silos. Think global and act local. Your site may be one of the hundreds, but your actions wave across the industry. Let your project be benchmark others aspire to. So I am giving a conclusion remarks. True sustainability starts with a single seed. I urge each of you to plant at least one tree and then inspire three more people to do the same, creating a growing legacy of life that outlasts any structure we build. Thank you.